So we've been told that y equals x minus a all squared. Now if it's all squared, it means x minus a times x minus a. So that's the same as, and when we expand that, we get x squared minus ax minus another ax minus a times minus a is plus a squared. We are then given some information about dy by dx. So we know what dy by dx ends up being, but from y equals this, we can work out our own version of dy by dx. So we can say, look, if y is worth this part differentiates to 2x, and that's already exciting because they've given us that dy by dx is 2x minus 6. So that's kind of our target. So we've done 2x, and this bit here, how many x's did we have? We had minus 2a of them. And so when we differentiate it, whatever the coefficient was, we keep, but x, which has a power of 1 there, goes away. This one has no x's in it, it's basically a constant. So that one does not even make it onto our differentiated version. So now we just compare this against that. And so if 2x minus 2a is in fact 2x minus 6, then 2a must be 6 and a must be 3. And that's our answer to part A. Okay, in part B, it's talking about what transformation would map the curve with this equation onto y equals x squared. We've got to be a bit careful here, but if we compare y equals x squared and the equation of c, which in this case is y equals x minus a all squared, transformations of graphs tells us that from here to here we have moved to the right by a unit. Well, in fact we know what a is, don't we? So it's x minus 3 all squared. So from here to here it's a movement right, a translation right by 3 units. But the question was sneaky, and the question said a transformation that would map this back onto that. So we have to go left. So our answer is in fact a translation left 3 spaces, and there's nothing going up and down. Okay. So we've got them 6. Curve with the equation y equals x squared plus 2x passes through the origin. So this is our original expression. And in part A, find an equation for the normal to the curve at O. So we have a point. We have the point 0, 0, so we have an x value to play with and a y value to play with. Because we want the equation of the normal, we'll need a gradient. And because we need a gradient, we need dy by dx. So we can say dy by dx is 2x plus 2. And so because we're interested in this point here on the curve, we can plug in when x equals 0, the gradient is, well, let's plug in the 0, so it equals 2. But we want a normal, and so the gradient of the normal is flip and switch that one, so it's minus a half. And so the equation of our normal will look something like this. Y equals minus a half x plus something, and when x is 0, we know y is 0, so we've got 0 equals minus a half times 0 plus c. Well, this makes 0, that is 0, so c would need to be 0, and therefore our equation is y equals minus a half x with no constant on the end. What's up? It's fine, I can pause it. Oh, okay.
I probably won't fall asleep, but
Got a lot from you. You want one? Not really.
a little.
No, it's been wet here.
Oh, I'm going to make a towel.
Kelly was complaining of dodgy stomach. Do you think it's sort of family affair?
Could be. Yeah, but just make it a bit more susceptible to trying to decide if I'd like some cold water, but then I think I'm going to feel like my tummy is like it here.
Have a sip just for the sort of. I won't be ages more. Okay, in part B, we're trying to find the coordinates of the point where the normal to the curve intersects the curve again. So obviously it already touches here, because that's where we kind of worked it out in the first place. And we're trying to find the other coordinates. So we must remember we need an x and a y coordinate. And at this point of intersection, we know that the equation of our normal will equal the equation of the original curve. If we just clean it up, add the half x on. A half plus 2 is 2.5x, but we can write that as 5 over 2x. Now we can factorize. We've got x in both of these, so we can write x into x plus 5 over 2. We already knew that one of the solutions was x equals 0, but now we've flushed out the other solution, and that one is minus 5 over 2. But don't forget that we need the other coordinate as well. So when x is minus 5 over 2, y equals, now we could plug in either into the original equation, x squared plus 2x, or we can just plug into this thing, which is much easier. Plug into minus a half x. So y equals minus a half x, which in our case is minus a half times minus 5 over 2, which actually gives us positive 5 over 4. And so the intersection happens at minus 5 over 2, 5 over 4. Okay, question 7. Question 7, we simply have to differentiate again, and then just do some plugging in. So the original equation really must be rewritten so that we have it in index form. It's much easier to deal with. So root x means it's x to the power of a half. Next term is negative. How many have we got? We've got 4 of them. The x is on the bottom, so the power of x is negative, and it's a square root, so it's negative a half. Don't forget, this is still just our original equation. We haven't actually done anything to it, just rewritten it. And so in part A, where we want dy by dx, we multiply the original power by the original coefficients. We get half x, subtract 1 from that power, so we've got negative a half. And then we've got minus 4 times minus a half, so that's plus 2. And x. And we drop that power from negative a half. If we drop it by 1 more whole unit, we end up on negative 3 over 2. And that's it for part A. For part B, we just go again. d2y by dx squared. Minus a half times a half is negative 1/4. Drop that by 1, takes us to minus 3 over 2. Here we've got minus 3 over 2 times 2, so that just gives us negative 3. Drop the power, it's minus 5 over 2. Now part C looks really complicated at first sight. Show that 4x squared times the answer we just worked out plus 4x times the original or the first differential minus y equals 0. Well, we've just worked that out. We also worked that out, and we know what y is because we've been given it in the first place. And in fact, we even have a nice index version of the original equation for y. So all we really need to do is plug everything in and just see what happens. So we have 4x squared multiplied by all of this. So because it's all of that, I better wrap it up. I've got half x to the minus a half plus 2x to the minus 3 over 2. And then it goes on to say plus 4x times dy by dx, so plus 4x times whoops, clever me, I've done d2y by dx, no, I've done dy by dx where it wanted d2y by dx squared, so never mind, we go again. Let's put in 4x squared times d2y by dx squared, so it's minus a quarter x to the minus 3 over 2 minus 3x minus 5 over 2. this time I plug in dy by dx, so what was it, a half x to the minus a half plus 2 x minus 3 over 2. And in the thing we're trying to prove, it also says minus y equals 0. Well, we have y from up here, and we're taking away all of y, so we've got to be careful that we're taking it all away. The signs could cause problems, so I'm going to wrap that up. Minus 4x to the minus a half. Now we're trying to show that all this stuff equals 0. So at the moment I'm not going to presume, I'm just going to hope that all of this ends up equaling 0. I can't put equal 0 yet because I'm not trying to solve it. I'm just going to see what it ends up equaling. And so let's do something with this. The only thing I can really think of doing is multiplying out the brackets and hoping that some stuff starts cancelling out. So let's multiply out the brackets. So all of that is equivalent to or equals, and now let's expand. 4 times minus a quarter is minus 1. So we've got minus 1x to the power of, well, the power here is 2, and the power here is minus 1.5, minus 3 over 2. 2 add negative 1.5, or 2 take away 1.5, just leaves us with positive 1/2. 4 times minus 3, minus 12, and power of 2 plus negative 2.5 means we end up on negative 1/2. Let's move on to the next bracket. 4 times 1/2 is 2. This is a power of 1, and then we're taking away 1/2 from it, so it'll leave us with a power of 1/2. 4 times 2 is 8, everything's positive. We have a power of 1 here, we're taking away 1.5, so the power we end up with is negative 1/2. And finally, let's deal with this. Basically we just have to switch all the signs inside because we're taking all of this away, so we're going to end up with a negative x to the 1/2, and minus minus 4 is plus 4x to the minus 1/2. And just to make it clear now, you could probably get away with just saying equaling 0 here, but let's just check that it has worked. Let's collect together all of the x's to the power of 1/2. So we've got this one here, then we've got this one, and then we've got that one. And then we'll do the negative 1/2, so we've got minus 12x to the negative 1/2 plus 8x to the negative 1/2 plus 4x to the negative 1/2. And as you can see, minus 1, minus 2, but plus 2 means we have 0 x to the 1/2. Over here, plus 8 plus 4 makes 12, but with a minus 12 we have none of those left either, and therefore overall the whole thing cancels out to leave 0. And there we go. And the last question, question 9. We're given the original equation as y equals root x minus 3 all squared. And we're told that this is really only valid as long as x is at least 0. So question A says, show that dy by dx equals something. So let us work out dy by dx and hope that we're in agreement. Before I can do anything with that, I better deal with the bracket. Bracket squared means this times by itself. So y equals root x minus 3 multiplied, by itself. If we FOIL this out, root x times root x times minus 3 is minus 3x, and then minus another 3x from the inners makes minus 6 root x. And minus 3 times minus 3 is positive 9. Now, before differentiating, it'd be good to just have indices rather than have surds kicking about. So we'll have x minus 6x to the half plus 9. And now we can happily differentiate, and the x becomes a 1. Minus 6 times a half is minus 3. Drop that power, and of course this is now equivalent to what we had in the first place, or what we were trying to show. It's 1 minus, how many of them? 3. But the x is hiding on the bottom because it has a negative power. What power does it have? Power of a half, which means square root. And so we have shown, as requested, that dy by dx is 1 minus 3 root x. And that was 4 marks, which is quite generous. Okay, B. We know that point P has an x coordinate of 4. And it says find an equation for the normal to the curve at P. If we're going to find the equation of a straight line, which is what a normal is, we're going to need a point and a gradient. Let's sort out the point first. If x equals 4, y we've been told is root x minus 3 all squared. Well, if x equals 4, root x is 2. 2 minus 3 is negative 1. But when we square it, we get a positive 1. Okay, so we have that point P is in fact 4, 1. And now we have a point, we now need a gradient at this point. Well, they've already given us what dy by dx is. We know it's 1 minus 3 over root x. So gradient at P is 1 minus 3 over root of x. Our x value is 4. Of course, root 4 is 2. So we've got 1 minus 3 over 2, which is 1.5. 1 minus 1.5 equals minus a half. So our curve has a gradient of minus a half, but we want the normal. So we need to flip and switch that. So the gradient of the normal equals, instead of negative 1/2, it's positive 2. And so our normal has an equation in this form. And we know that when x is 4, the gradient is 2. We know that we need to hit a y value of 1. Well, 3 times 4 is 8. 8 plus what equals 1? Plus negative 7. And therefore, our equation that we wanted was y equals 2x minus 7. The last part of the question. Okay, so the equation of normal has to equal the equation of the curve. So we've set that up, And if we just collect everything on one side, let's see what happens. If we bring everything over to the left, 2x minus that x just leaves us with a single x. Negative 7, take away that 9, will leave us with negative 16. And then if we get rid of that, it'll come up as positive 6 root x. Now this probably looks slightly unfamiliar. You could think of it as a quadratic in disguise, but it certainly can be factorized. If we think about how we might end up with negative 16, it's going to have to be a plus and a minus. Because that is a positive 6, I'm thinking plus 8 and minus 2. But of course we're dealing here in root x's, not in x's, so these guys will have to be root x and root x. And just to check that it foils out properly, root x times root x does give us x. 8 root x minus 2 root x gives us positive 6 root x. 8 times minus 2 is minus 16. And so this would just suggest that root x is either 2 or root x is negative 8. Now in this case, this does give us the answer. If we square both sides, x is 4, which we knew because that's the point that we've worked out before. But then this one we are told, well, the root, the square root of a positive, of that positive number cannot be minus 8. There's no way. If we're trying to take the square root of something and we've got it being negative, that will not work out. And so there are no real solutions to find there.